Dear students, under the topic polar coordinates, we are finding the angle between the radius vector and the tangent for a given curve. Now here the given curve is 2a by r equal to 1 minus cos theta. The first step is we have to mark the given curve as equation 1. And then we have to differentiate equation 1 with respect to theta. When we do so, what we get is, on the left hand side, 2a is a constant, so it comes as it is. The differentiation of 1 by r. For this, we have to apply the differentiation formula, where we know that the differentiation of x to the power n is equal to nx to the power n minus 1. Now here we have 1 by r. So this can be rewritten. So 1 by r can be written as r to the power minus 1. So when this is differentiated with respect to theta, the differentiation of r to the power minus 1 is, here the value of n is equal to minus 1. So it will be minus 1 r to the power n minus 1. So n is minus 1. So minus 1 which will be equal to minus r to the power minus 2. And this can be written as minus 1 by r square. So the differentiation of r to the power minus 1 is minus 1 by r square, and by using the chain rule method, r has to be differentiated again with respect to theta, which will be dr by d theta. So therefore the differentiation of 1 by r is minus 1 by r square dr by d theta. So let us write that here. So 2a multiplied with minus 1 by r square dr by d theta is equal to, on the right, when 1 is differentiated with respect to theta, it will become 0 because 1 is a constant, and minus the differentiation of cos theta is sin theta with a negative sign, that is minus sin theta. So minus sin theta. So let me write the formula that we have used just now, that is the differentiation of d by dx of cos x will be equal to minus sin x. So this formula we have used here. So the differentiation of cos theta will be minus sin theta. So on the left we are having minus 2a by r square dr by d theta is equal to, minus into minus will become plus, and sin theta. So from this we can write what is dr by d theta by taking this complete term to the right. So what we get is dr by d theta is equal to minus, so this r square gets multiplied over here, so minus sin r square sin theta, and 2a comes to the denominator, so divided by 2a. We are supposed to find the angle between the radius vector and the tangent for the given curve, for which we will be using the formula tan phi is equal to r multiplied with d theta by dr. Now here we have found dr by d theta. So we have to rewrite it as d theta by dr. That is, we have to take the reciprocal of this. So therefore the reciprocal of this will be d theta by dr, which is equal to minus, so 2a goes to the numerator. So 2a divided by r square sin theta in the numerator comes to the denominator. So it will be r square sin theta. So therefore we have obtained d theta by dr, which we have to use in this formula. So as the next step, we shall write this formula and we shall proceed. So therefore, the angle between the radius vector and the tangent for the given curve can be written as tan phi. This phi is the angle, okay? Tan phi, which is equal to, by using this formula, that is r into d theta by dr, we have to write here. So r into d theta by dr, which is equal to, now let us substitute this that we have found. So r multiplied with, what is d theta by dr? We have a minus sign which we will put here. Then 2a divided by r square sin theta. Now we can cancel this r and one of the r in the denominator, and so this will be equal to minus 2a divided by r sin theta. Now this can be written as 2a by r, this minus we will have out, 2a by r multiplied with 1 by sine theta. Why I am writing like this? Because I want to make a substitution here. We know that from the given question 2a by r is equal to 1 minus cos theta. So we can replace 2a by r with 1 minus cos theta over here. So therefore this will be equal to minus of 2a by r is 1 minus cos theta divided by this sine theta which is there in the denominator. So divided by sine theta. Now here we are going to make use of two trigonometric identities. That is, one of the identity is, from the trigonometric identity we know that 1 minus cos theta is equal to 2 sine squared theta by 2. So this is a trigonometric identity. The other trigonometric identity which we will be using is sine theta is equal to 2 sine theta by 2 multiplied with cos theta by 2. Now these two trigonometric identities we are going to make use of. So in the numerator 1 minus cos theta can be replaced by 2 sine squared theta by 2. So here this can be written as minus of and 2 sine square theta by 2. And in the denominator sine theta can be written as 2 sine theta by 2 cos theta by 2. So we will write here 2 sine theta by 2 cos theta by 2. Now if you see, this 2 and this 2 can be cancelled. One of the sine term in the numerator and this sine theta by 2 can be cancelled, and so we are getting tan phi. Okay, this tan phi to be equal to what? Minus, in the numerator we have sine theta by 2 left out. So sine theta by 2 divided by, in the denominator we have cos theta by 2. And what is sine by cos in trigonometry? It is tan. So sine theta by 2 cos theta by 2 can be written as negative, because this minus we have, and this is tan theta by 2. This is because we will write the trigonometric identity that we have used. So what we have used is, we know that sine theta by cos theta is equal to tan theta. So therefore here we have sine theta by 2 divided by cos theta by 2, which is tan theta by 2, and this negative sign has come as it is. Now we have tan phi to be equal to minus tan theta by 2. So this is what we have. Now if we want to compare the angles on both the sides, it should be same. But if you see here, we have tan phi and here we have minus tan theta by 2. So we cannot equate phi to be equal to theta by 2 because of this minus. So we have to get rid of this minus, for which we will be using one of the trigonometric identity. So the seventh identity that we are that is formula that we are going to make use of is, we know that tan 180, so 180 is represented as pi. Tan 180 minus theta is equal to minus tan theta. So now we are going to make use of this. Here we have minus tan theta by 2. So here we have minus tan theta by 2. So this can be written as, by using this identity, instead of minus tan theta by 2, we can write it as tan pi minus theta by 2. Because we had theta here, we have theta. But what is required now? Minus tan theta by 2. So we can write that as tan pi minus theta by 2. So on making use of this identity, we can write this as, so minus tan theta by 2 can be written as tan, okay, pi minus theta by 2. So by just now I showed you the identity. By making use of it, we can write it. So therefore tan phi is equal to tan pi minus theta by 2. Now we can compare both the angles, or we can say, taking tan inverse on both the sides, the angles will be same. So phi will be equal to pi minus theta by 2. So therefore we have found the angle between the radius vector and the tangent to the given curve to be equal to pi minus theta by 2. Hope you have understood this problem. In our next video, we will learn how to find the slope of the tangent for a given curve. Thank you.